Hello students, welcome to EPG Pathshala. I am Dr. Hemant Sharma from MIT University, Haryana, Gurgaon. Today we are going to talk on module Multiple Regression Analysis under the paper Quantitative Techniques for Management Decisions. After completing this module, the students would be able to develop a multiple regression model to understand the hypothesis tests about the regression coefficients, to calculate a prediction interval for the dependent variable, to analyze residuals in order to check the validity of the models, calculating multiple coefficients of the determination, and to perform a Durbin-Watson test for autocorrelation in the residuals, to understand the concept of the multicollinearity, and to test the goodness of fit of the proposed multiple regression model. Multiple regression analysis comes after the simple regression analysis. In simple regression analysis, dear students, we had only two variables, one dependent variable and one was dependent variable. And in multiple regression analysis, we have one dependent variable and many independent variables. So here we are trying to predict the value of dependent variable for the given values of the different independent variables. So it is very useful uh, concept for the decision makers in business organizations, in various governmental departments, because they are always interested in you know assessing the effect of the various independent variables on a dependent variable. So, a future is full of uncertainties, and we know predictions are never perfectly correct. Therefore, we want to make predictions on the basis of some scientific theory, scientific knowledge that is being provided by the multiple regression model. Multiple regression analysis assumes a linear relationship between the variables like the correlation analysis, and again it is not talking about the cause and effect relationship between the variables under the study. That can be ascertained only by the covariation study of the covariations among the variables. As we have seen that in multiple linear regression model, we have one dependent variable and two or more than two independent variables. This model is also assuming a linear relationship between dependent variable and every independent variable. So in this slide you can see that y is equal to beta naught plus beta 1 x1 plus beta 2 x2y plus beta 3 x3. So here beta naught, beta 1, beta 2, beta 3 are the constants parameters of this equation, and x1, x2, x3, these are the independent variables. And if we write it in a determinant form, it would be y is equal to determinant y1, y2, yn, x is equal to x1, 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 x2, like that, and beta is equal to beta 1, beta 2 up to beta n for I is equal to n observation, alpha is equal to alpha 1, alpha 2 to alpha n. So in this equation, parameters alpha, beta, which we will calculate, estimator, the complete right hand side is the estimator, and estimate, this is a number or a specific value that is computed using the estimator. Assumptions of multiple linear regression analysis. It is good to appreciate all assumptions of the multiple regression analysis in advance, because the accuracy of our prediction would be higher only and only if we meet all these assumptions. First assumption of multiple regression is linearity of regression model. Linearity of regression model means the mean of our error term is equal to 0, and it can be ensured by plotting the residuals against every independent variable, and there should not be any apparent pattern in the plot for a fit regression model. If we see any apparent pattern, it means the errors are related to each other, and our it would be a violation of the linearity of the regression model. Second important assumption is the homoscedasticity. It is also termed as constant error variance. So if we write it symbolically, it would be variance of error term is equal to constant. It requires that variance around the regression line plane must be constant for all the values of independent variables. For this, we can plot the residuals against the estimated value of y, and obviously if residuals show equal fluctuations around a zero mean, it means assumptions of constant error variance has been met, otherwise not. 10 number, independence of error. It is very important assumption of the multiple regression analysis. It means that the value of error for any specific value of any independent variable x must not be related to the value of the error for any other value of that independent variable x. This is also known as autocorrelation. For this, errors are plotted on y-axis and observation order on the x-axis. If errors show a random pattern around a zero mean, it means our errors are independent. It is also done with the help of the Durbin-Watson statistics. The next assumption is the normality of error. It assumes, it says that our errors must be normally distributed. So it's very easy to see the normal distribution of our error with the help of the histogram. In histogram, we can take the error on the x-axis and frequency on the y-axis, and this histogram will show the normality of error. So these four are the main assumptions of the multiple regression analysis, which are usually met using the residual analysis. So what are the properties of the good estimator in multiple regression analysis? So it's almost similar to the simple regression analysis as we discussed in the previous module. Lower computational cost, highest coefficient of determination, linear estimator, unbiased estimator, minimum variance of the estimator. Multiple regression analysis, it is good to note in the figure here we have two or more than two independent variables. So in place of any regression line, here we have a regression surface that is also known as response surface with respect to the independent variable. Now we need to think something over the regression model. Least square estimation. Suppose we consider a multiple regression model with two independent variables. So here we have three unknown variables, three constants beta naught, beta 1 and beta 2. So obviously we need to have three normal equations to find out the value of these constants. So method of least square suggests the following three normal equations to find out the values of three unknowns, and we can find out the value of b0, b1 and b2, and after that corresponding values of B0, B1 and beta 0, beta 1 and beta 2. Here this graph gives a very good estimation about the different types of the errors. So here y is the actual value of the variable and y bar is the mean value and y cap is the estimated value. So here error deviation is y minus y cap, actual value of variable, dependent variable minus estimated value of dependent variable. So this would be the error deviation, total error. And deviations which are explained by our regression model is equal to y cap minus y bar. So these deviations have been explained by our regression model and total deviations y minus y bar. These are the total variations in the dependent variable. So out of total deviations, some deviations are explained by our regression model which are known as SSR, and remaining variations are the error deviation, usually represented by error deviation SSE. So total deviations is equal to SSR plus SSE. Testing the goodness of fit of the proposed model. So here we also need to see whether our proposed model is good enough to make the prediction or not. So for this, we have the various parameters to ensure whether our parameter is model is good or not. Number one, it is coefficient of determination, R square, F test, and we can also test the significance of the parameters of the model individually using the t-test, and residual analysis, which we have already discussed, and standard error of estimation, undoubtedly the most commonly used parameter of our estimation. F test to test the overall significance. Here we can use the F ratio value to test the overall significance of the model. So here in the previous model we have already discussed that F test is used to find out or to see the significance of the relationship between the dependent variable and the independent variable. So here null hypothesis is beta 1 is equal to beta 2 is equal to beta 3 is equal to 0. So we assume that there is no relationship between the dependent variable and any independent variable. And alternative hypothesis is that there is a significant relationship between the dependent variable and at least one independent variable. So if the value of f is found to be significant, it means there is a significant relationship between dependent variable and independent variable. So our model is found significant. So this is the ANOVA table that is usually produced by the various softwares when we are running the multiple regression analysis using that software. So here we can see that F ratio is a ratio between the MSR and MSC. MSR means mean of square of the regression and mean of the square of the error. How good is the regression? So here in you must be remembering in simple regression analysis we calculated the coefficient of determination R square. Here we need to calculate multiple coefficient of determination, that is R square. So R square is equal to variations explained divided by the total variations. So it is equal to SSR upon SST. As the value of R square increases, the goodness of our regression model also increases. Higher the value of R square, better the model is for the prediction. Standard error of estimation, as I have already told you, that standard error is the undoubtedly most important parameter to see the worth of our model. So it should be as least as possible in our prediction. So it can be calculated as under root MSE, as you can see in this slide. So this slide will give you a synoptic view of the total variations which are decomposed in two portions. variations explained and variations not explained. Explained variations can be calculated using the R square, and here you see one more thing, adjusted multiple coefficient of determination. So this is the coefficient of determination that is used to explain the variations of our model for the different population, for the different number of the observations, because as the sample changes, observation changes, their degree of freedom also changes. So it can be applicable for the different samples. Testing the significance of the individual regression parameters. So we have different independent variables. We have the values of beta 1, beta 2, beta 3. So every value is signifying a relationship between the dependent variable and the independent variable. So using the t-test, as already discussed in the simple regression analysis, using the t-test we can be ensure whether this value of beta 1, beta 2 or beta 3 is significantly different from 0 or not. If it is significantly different from 0, it means there is a significant relationship between the dependent variable and that independent variable, and this must be retained in the proposed model. In this slide you can see the various residual plots for an export company. So this is already inbuilt in the software like SPSS or Excel. These softwares are giving you the ready-made graphs for the residuals, for the errors. So by inspecting these all graphs, you can see whether we are meeting our assumptions of multiple regression model or not. Now once we have ensured about the goodness of fit of our model, now what is the next thing? Now multicollinearity is a very specific problem in the multiple regression analysis. As we know that in multiple regression analysis we have two or more than two independent variables, and when these independent variables tend to show a relationship among themselves, so that relationship can also affect the variations in the dependent variable. So it is a very complex scene when independent variables and the relationship developed between these independent variables together are trying to explain the variations in the dependent variable. So here the picture becomes very unstable, because we would not be able to segregate the contribution of the every independent variable in explaining the variations in the dependent variables. We can't segregate their individual contribution in explaining the dependent variables. So this makes our regression model very unpredictable, unstable, because since we don't know the contribution of every independent variable, a very small change in the value of one independent variable can bring a drastic change in the dependent variable, and sometimes a big change in the value of any independent variable may not bring even a very small change in the dependent variable. So our prediction model will become very unstable, and which is usually not preferred by the researchers. So this problem should not be there. We must avoid this problem, and to avoid this problem, what can we do? What can we do for that? For avoiding this problem, we have two or three choices. Number one, do nothing. Okay, whatever amount of multicollinearity you have in your model, you proceed with that amount. Otherwise, you can get a new data, new sample set where you don't encounter with the problem of the multicollinearity, or you can re-specify the specification of the models of drop some variables, independent variables, because of which this multicollinearity problem arises. And there is also a statistics, that is VIF, variation inflation factor. It is actually a ratio equal to 1 upon 1 minus RK square, variation inflation factor, and it is a statistical measure of the multicollinearity. Higher the value of VIF, higher the amount of the multicollinearity. So it can be used by the researchers to be sure about the multicollinearity. And apart from this, covariation matrix is there. You can also study the covariance matrix, that is representing the relationship among different variables, and if there is a stronger relationship between the variables, so we must avoid these variables to take in the multiple regression model as the independent variables, because this higher amount of the relationship between these variables is certainly going to create the problem of the multicollinearity, and that will be adversely affecting the prediction capability of our multiple regression model. So next thing is the problem of the multicollinearity and problem of the autocorrelation. These are two major problems in the multiple regression analysis. Problem of multicollinearity is occurring because of the relationship between the two independent variables, and problem of autocorrelation occurs when the error terms tend to be related with each other. So we need to remove these two errors for the better results. Here we have Durbin-Watson test. So here we can use this test to ensure that we have met the, or we have removed the problem of the autocorrelation. So value of F ratio can be calculated as shown in this slide. MSR divided by MSC. MSR is the mean sum of the regression and mean sum of the error. So if value of F is found to be significant, it means there is a significant relationship between the dependent and independent variables, and overall significance of the model is good. We can go ahead with this model. And usual R square, it's good to have the value of R square greater than 60%. Otherwise, there can be a problem in the estimation. Standard error of estimate is also calculated in order to see the adequacy and the reliability of our proposed model. Lesser the standard error, more reliable our model is in the prediction. Multiple regression model are based on some assumptions. These assumptions can be met using the residual analysis, and there is also a problem of the multicollinearity, which has already been discussed in detail. So in case of the multicollinearity, we must go for the other data set, or we can drop some variables which are creating the problem of the multicollinearity, or do nothing. We have no other option to avoid the problem of the multicollinearity. And it is not necessary that there is always a linear relationship between the dependent and independent variables in our multiple regression model, which is the main assumption of our model. It is not necessary. There could be a curvilinear relationship between the dependent and independent variable. It could be exponential relationship, any kind of relationship other than the linear relationship. So in that case, we cannot go with the multiple linear regression model. And if we wish to use the multiple linear regression model in the prediction for that kind of the relationship, we first need to transform the variables in such a way that they tend to show a linear relationship. It can be done by the different types of the transformation it can be exponential transformation, it could be log transformation, it could be reciprocal transformation. So it depends. The important thing is, by transforming the variable, they must show a linear relationship. Thank you very much.